Welcome to Protocol Particulars, a video interview series where we chat with members of the ASAP community who have developed protocols about their protocols and some of the tips and tricks that they have to tell the community about the work that they are working on. So for today's video, I have with me Daniel Saarela. Daniel, I'm going to pass the mic over to you and let you just tell us a little bit about who you are and what CRN team you're on and the project that you're working on with ASAP.
Hi, yeah, thanks, Devin. So my name is Dan, and I'm a final year PhD student in Dario Alessi's lab, and I'm part of the Team Alessi. I've been mainly working on developing methods to study lysosomal dysfunction, and I've also investigated how LRRK2 is implicated in lysosomal homeostasis.
Thanks, Dan. So today I have you here because we're going to talk about a video that your group created where you guys show the steps from a Tagless LysoIP protocol that your team developed. And I was hoping before we go into that protocol, if you could just tell us a little bit about the video. So your team already has a step-by-step recipe style written protocol for this, but I was wondering what the motivation was for actually making the video that people can watch.
Yeah, so the idea actually came to me when I realized that despite me sharing and showing this protocol to a lot of people in the lab and in like the labs in Dundee, but also our external collaborators, there was always some questions that came up and that you wouldn't be able to put into words very easily, like questions about, oh, I might have a leakage in the machine when I do it like this. How should I orient these things and all that. So there were always something small that they were struggling with, and I was really struggling to figure out how to put that into words. So I thought making a video on this, because it's quite a technical method. Like it's not just putting liquids into liquids sort of thing. There's just a little bit of hand dexterity required. So I thought it would be good to make a video because of that. And also it uses a ball bearing homogenizer, this method, which is a specialized piece of equipment that isn't really widely used. So introducing that to people would be also very useful in a video format.
Yeah, I actually took a look at this video earlier and I saw the homogenizer, and it was different than the homogenizers that I had used in the past. And so it was really interesting to see how that works. So, for anyone who is going to be trying to actually carry out this protocol, I was hoping you could go into some of the steps that are like especially critical for people to actually be successful while they're carrying out the protocol.
Yeah, absolutely. So I would say this method was kind of developed with clinical translation in mind. So I've been working a lot with clinical samples like isolated cells from peripheral blood and so on. And the first tip I have is if you're working with isolated cells from blood, you need to include diisopropyl fluorophosphate in your homogenization buffer. And this reduces the degradation of your proteins in your sample, and it is needed because there are some neutrophil-derived proteases in blood. So that is the most important thing if you are working with clinical samples, because then you're going to otherwise struggle to see the proteins that you're interested in. Secondly, it's very important that in the homogenization buffer as well, there's no detergents whatsoever, because we are trying to break cells with this method with physical shearing force effectively. So if you have any detergents, you might actually break all the membranes in the cell, and we're really looking to break only the plasma membrane and keep the organelles intact. So no detergents in the homogenization buffer is very important. The rest of the tips are actually kind of to do with the homogenizer itself and the homogenization process. It's really important, for example, to optimize the size of the gap that is inside the device when you homogenize. So effectively, this device has a small gap inside it that you pass your sample through. And the gap size changes based on what kind of cell you're using. So when you purchase one of these homogenizers, or if you have one of these already, the kit comes with these different gap producing ball sizes. So they are from 4 micron to 18 micron of gap size. So if you have larger cells, you use larger gap and so on, because you need to balance the sort of how much pressure you're producing in the device itself with the actual homogenization efficiency. So optimizing that is important. I have in the protocol actually mentioned a couple things I've worked with and what gap size works for those. Additionally, it is important to make sure that the device is kept on ice at all times, so you keep it at 4 degrees, and you want to handle it with secure grips, so you want to make sure it's securely on ice, you're keeping it in your hands, and because you are pushing the sample through this tiny, tiny gap. You're introducing a lot of pressure to these syringe inserts that are in the machine. So making sure that it's always sealed tight is very important so you don't end up spilling any of your precious, precious sample. Keeping a constant pressure as well while you're homogenizing is very important to reduce any bubble formation. And following the homogenization, it's important to only use fully solubilized homogenate when you go forward to the immunoprecipitation steps. So taking care not to take any pellet up when you're pipetting the supernatant out, or any foam or anything that is like floating in the homogenate, so to speak. And very lastly, when you're done at the end of the day, working on the homogenizer, make sure that you wash it with ethanol and wipe it dry and leave it disassembled overnight as well to air it out. And even between samples, it is important to open up the machine and quickly rinse it out so you don't end up clogging it with any sort of cell debris between samples.
Yeah, that makes sense. Thanks for covering all of that, Daniel. We actually do have a clip from the video that Daniel produced showing some of these steps with the homogenizer, so you can actually view that clip now.
Take up your cell suspension using a 1 milliliter syringe and a large bore needle. Insert the syringe onto the homogenizer, making sure it and the homogenizer are well secured and sealed tight. To homogenize the cells, use the plunges in the syringes to pass the sample back and forth through the chamber 15 times. The cells will break by physical shearing force when they are forced through the 12 micrometer gap at the ball bearing. Make sure you keep the syringes pressed down at all times to keep the seal from breaking and spilling your sample. Your sample should provide resistance to the plunges, but if you find extreme difficulty passing your sample through, consider a larger gap size inside the device using a different ball or reduce the amount of cells homogenized.
And so, Daniel, just a couple more questions. For people who are wanting to actually watch the whole full video, where would they actually be able to find that?
Yeah, so this video is linked to the protocol's IO method for this Tagless LysoIP, and it is called the isolation of lysosomes using the Tagless LysoIP method in PBMCs. So you should be able to find that on protocol's IO.
Thanks. And before I let you go, I just wondered if you had any final thoughts that you would want to leave people with.
Yeah, well, thank you firstly for having me here. I'm now nearing the end of my PhD, and I wanted to thank actually ASAP for the wonderful research environment that it has provided me with. And I've really enjoyed being able to interact and collaborate with many ASAP teams over the last 4 years. And finally, I would like to announce that my first manuscript is actually now out on bioRxiv as a preprint, and it uses this methodology we were talking about today. And this preprint is called Tagless LysoIP method for molecular profiling of lysosomal content in clinical samples. So please go and have a look at that as well, and you'll see the results that this method can provide.
Thanks so much, Daniel, and congratulations on your first preprint.